I want to go through a couple of these problems with the law of sines that we talked about, like the ones that we talked about today in class, and then I'll go through and post solutions to the rest of them. So you'll see a video on YouTube if you want to listen to me explain some of them, and the rest will just see solutions. So remember, for law of sines, we use the relationship that sine of alpha over A is equal to sine of beta over B is equal to sine of gamma over C. So this means that we have to have three of these pieces to be able to plug into a particular equation to be able to solve for the pieces of the triangle that we want. I know some of these particular ones just say find a particular side or a particular angle, but for our purposes, we're going to be solving triangles, finding all of the pieces of information. So in this case, we'll need to figure out what this angle is. This is beta, since that's the angle at B. We'll need to figure out this side A, because that's the one that's across from A, and this side C. So those are the pieces that we need. Well, let's do beta first, because beta is pretty straightforward. It's the third angle in the triangle. So it's 100 minus 58 minus 93. So if we do the 180 minus 58 minus 93 on our calculator, we get... Now that we have beta, we can use it across from the side 16 to help us figure out the other two. So let's do A first. We need sine of alpha over A equals sine of beta over B. And remember again, pardon me, remember again that we're going to use two of these pieces in this relationship that we have among the three. We're going to only use two at a time, depending on what we're trying to solve for. Alpha is 93 degrees. Beta is 29 degrees. And B is 16. Cross multiply. So we get A sine of 29 degrees equals 16 times the sine of 93 degrees. Divide by the sine of 29. Get 16 sine of 93 degrees over sine of 29 degrees. And now it's time to go to the calculator. Double check that your calculator is in degree mode in these. So you need to go down and put it in degree mode, just to make sure that we're all in the same place. All right. So we do that in this case. We have 16 sine of 93 divided by sine of 29. And we get about 32.9574. If I remember, Hawks wants you to round to 4 decimal places. I think that's right. But if not, I do want you to round to 4 decimal places. All right. So now it's time to figure out C. Now, we could use alpha and A to figure out C. But remember that A is a rounded value that we just have. And it's always better to use the given values to us if we can. Sometimes we can't avoid it and we have to use a rounded value. But in general, if you do a rounded value for a future computation, you start compounding rounding errors as you go along. So it's always better to go back and grab one where you know what the value is without rounding. So let's use sine of beta over B is equal to sine of gamma over C. Beta is 29 degrees again. B is 16. Gamma, that's the angle at C, is sine of 58 degrees. Don't know C. And now we do what we were just doing in the previous problems. We cross multiply. And then divide to solve for C. And now it's time for your calculator. So we have 16 sine of 58 divided by sine of 29. And get roughly 27.9878. So these three values that we found solve the triangle that we had started with. Solve triangle ABC. All right. So this is the basic principle that you use for using law of sines. Now, one of the things we talked about today in class was the idea of if you have to solve for an angle, you have to be careful, because if you solve for an angle first, you might get two triangles, you might get one triangle, you might get no triangles. In this case, we knew we were only going to get one triangle because we had angle, side, angle. That's a congruence theorem. Here's another one where we're given side, angle, side, and we're also given side, side, side. That's a congruence theorem. What's not a congruence theorem is side, side, angle. So two sides and an angle, but the angle's not in between the two sides. So that's the case where we might get two triangles. And that was what we saw today in number 11. And again, I'll post solutions, so I don't want to redo number 11 again. But let's look at number 12 here. This is another one where we're going to have to solve for an angle first. So, and I know I'm orienting my triangle. It doesn't really matter. Again, ABC. So I know A is 28. That's the side of opposite angle A. I know B is 27. And the measure of angle B, which I usually call beta, is 45 degrees. So we want to find little c, we want to find alpha, and we want to find beta. Notice I can't find, oops, this is not beta, this is gamma. Beta is the one with B, that one's gamma. I notice I can't immediately solve for gamma or c because I always use angle and side opposite. Those are two different things, I don't know either of them. So I better solve by trying to find alpha. So we'll use sine of alpha over A is sine of beta over B. Alpha, I don't know, but A I know is 28. B is, or beta is 45 degrees. B is 27. Cross multiply, we get 27 sine of alpha. Cross multiply in this case, I'm not going to do that. All I need to do is multiply by 28. Sine of alpha is 28 sine of 45 degrees over 27. And then I have to do inverse sine. Okay, so I get inverse sine of 28 sine of 45 over 27. So we'll do inverse sine. 28 times sine of 45. Make sure you close your parenthesis. Divided by 27. Then we get roughly 47.1634 degrees. Okay, this is one angle. So right now we have alpha is equal to 47.1634. We know beta is 45. Okay. I can figure out gamma from that. What I want to do first, immediately, is check if there's a second triangle. Okay? We always check to see if there's two triangles if we use the law of sines to find an angle. Okay? So the only time we have to worry about it. If we do that first, if we use the law of sines first to find an angle, we want to check to see if there's a second triangle. That's important. Okay? The way we check is that we take the alpha and do 180 minus 47.1634. So if I do that in this case, do 180 minus that previous answer, I get 132.8366. If I add that to the 45 degrees, notice I get 177.8366. That's less than 180. We have two triangles. Okay? Because this is less than 180, I can find another angle. Okay? So for this one, we can figure out what gamma is. Let me go back up. To that one. Our alpha was the 46.1634. we need to do 180 minus 45 minus that angle. Our gimbal will be 87.8366 degrees. We also could have, let's go back up again to grab this entry. This was our other potential alpha is 180 minus that, which is the 132. We added the 45, that was the beta, and now we subtract it from 180. The other possible gamma is that small one. So for triangle 2, your beta is still 45 degrees. Your alpha, though, in this case is 132.8366, roughly. Your gamma is roughly 2.1634 degrees. But now we're ready to find C. All right. We know beta and we know B. Those are not rounded, so let's use that. We'll have to use the rounded value for gamma regardless, but this one we have sine of beta over B is sine of gamma over C. Beta is 45 degrees. B is 27. C, I don't know, but gamma we know is 87.8366 degrees. Just in the interest of time, I'm going to cross multiply and divide all at once. So we get 27 sine of 87.8366 degrees over sine of 45, which is going to be approximately what? So 27 sine, I'm just going to type it in, even though it might give me just a tiny rounding error, divided by sine of 45, and we get 38.1566. So these three that I'm circling correspond to one triangle. For the other one, we're going to do the exact same computation with the beta. I'll have sine of 45 degrees 27 equals, well, the other possibility for gamma was the 2.1634. So I'll do sine of 2.1634 over C. The steps are the same when solving this. You just have a different number inside the sine. So we'll have 27 sine of 2.1634 divided by sine of 45. And we get roughly 1.4414. And now these go together for your second triangle. So this is another example of getting two triangles when we solve for a particular angle. All right, let's see if we can get one where maybe we either only get one triangle or we don't get any triangles. Let's look at 14 here, where we have measure of angle B is 73, A is 7, and B is 5. So if I do A, B, C, again, it doesn't really matter where you put the letters as long as you put everything in the triangle the way it's supposed to go. 73 degrees was the measure at angle B, 7 is A, 5 is B. Need to find alpha, gamma, and C. Again, in this particular one, we're going to need to find alpha first. So we have sine of alpha over 7 is sine of 73 degrees over 5. That's sine of alpha over A equals sine of beta over B. First, get sine of alpha by itself. So 7 sine of 73 over 5. And then do the inverse sine. And now let's use our calculator. Inverse sine, 7 times the sine of 73 divided by 5. Error domain. So what's going on with this? Well, let's go back in here and delete this out and just do this part. Do what's on the inside of the sine function. I get 1.3388. So really, at this point, we had 1.3388. So it says the sine of an angle is something bigger than 1, which can't happen. So as soon as we get to this point, we know there is no triangle, and we're done. That's the whole problem. Okay. So when you're going through this and trying to solve for alpha, notice I just went through and did it all at once. If I would have stopped right here and put it in my calculator, I would have noticed that this value is bigger than 1, and I would have been done. And that's the end. So I get no triangle there. Let's look at another one. Let's not do 16 because it looks like it's the same thing. Let's look at 15. Maybe I'll look at 15. Oh, it's because I'm trying to do a screen. Go. What are you doing? Apologies for having to pause there for a second. My pen decided it didn't want to try to work. All right, let's draw our triangle. A, B, C. Angle A is 117. A is measure 16. B is measure 38. B has measure 38. I put that in the wrong spot. Sorry about that. Again, we're going to try to solve for alpha first, but we still need beta and C, or excuse me, gamma and C if we can figure out an alpha that actually works. So from this relationship, we see that the sine of beta, which is 117 over 38, has to be the same as the sine of alpha, which I don't know, over 16. Alpha is 16 sine of 117 over 38. I'm going to go ahead and type this in this case to see if I get the same issue that we had in the last one. Notice that this is less than 1. This is approximately 0.3752. So I can do the inverse sine. So just use the calculator, inverse sine of the previous answer, and we get a 22.0342. Now I said that when we do use the law of sines to find an angle, we should always see if there's a second triangle. Well, in this case, that's a pretty easy thing to do. Notice that this angle is already 117 degrees. If I do 180 minus 22, I'm going to get something that's bigger. When I add it to the 117, that's going to be bigger than the 180 that a triangle could be. In particular, if I have a triangle and it has an obtuse angle, you can only have one obtuse angle, obtuse being greater than 90. You cannot have two angles that are greater than 90 in the same triangle because they would add up to greater than 180. But just to do the check that we would do, just to show you what I mean, alpha could also be 180 minus the 22.0342. So do 180 minus the previous answer. That is about 157.9658. Add your 117 for the beta. That gives you 274.9658 degrees, which is certainly greater than 180. So that tells us we get one triangle. Okay. We don't get a second triangle. This has to be less than 180 to get a second triangle. All right, so going through the rest of this then, we know that our alpha is 22.0342. That means our gamma has to be 180 minus 117 minus the 22.0342. So in this case, if I do 180 minus 117 minus 22.0342, we get 40.978-ish. And now finally, we're ready to get the last one. If we do sine of 117 over whatever the b was, 38, equals the sine of gamma, which is 40.9658 over c. C has to be 38 sine of 40.9658 over sine of 117, which gives us roughly what? We do 38 sine of the previous answer divided by sine of 117 gives us 27.9606. So this value, along with the alpha and the gamma that we found, solve the triangle. But again, in this case, even though we had to use the law of sines to give us one of the angle first, we still only got one triangle. So again, it's important to check that each time to make sure that you get 0, 1, or 2 triangles. Make sure you're in which case it needs to be. Again, you only really need to worry about that if you're using the law of sines to solve for an angle first. Like I said, I will go ahead and get solutions written up to the rest of these so that you can see those posted on Moodle, and I'll get this video posted on YouTube.